Hello, Glowbusters. Yes, of course they're serious. You do? You have? No kidding. Uh-huh. Oh, they'll cure your globitis this week. Thank you. We got one!
Ladies and gentlemen, it's the Glowbusters.
What are you supposed to be, some kind of a cosmonaut?
No, we're exterminators.
And now, here's your host.
And welcome everybody to Glowbusters, NASA, not a space agency. I am your host, Bob Xanadude60, and we are back with another Wednesday night show for you tonight. And we're having a little bit of trouble getting John the Morgile in on this, so let me work on that for just a second, guys, here, and I'll get back to you. In the meantime, Zack, we want to introduce you and Cami?
I think we're muted there, Zach. I'll introduce us. Hi, everybody. This is Cami. I'm the host's wife, and I'm your temp while waiting for the Morgile. Welcome, everybody. I'm so glad you can join us. Zach, now our regular Glovebuster. Have we figured out the mic yet?
Yeah, my mic was muted too, and that was throwing me off a little bit. I was double muted there, so sorry about that. Yeah, today's show we're going to be talking about how NASA has been making some really boneheaded errors still lately. Nothing new, same as always, but it should be a lot of fun. Astronomers finding new moons around Jupiter, and these are amateur astronomers. What do we, I mean, yeah, there's a bunch of neat stuff to cover today, so it should be fun. And then we're going to go strictly over to Rockfin for a little bit and talk about some things we're not allowed to talk about here that we want to bring up because they're really big. And yeah, I think people need to hear them.
Awesome. Okay, and I think we got Morgile on here. John, did we get you? Hello, John. Are you there? You see you on the call. Oh, there you are.
I'm here.
Yay! I hear you.
Okay, sorry, I don't know what's going on. My computer's still like black screen. It says getting Windows ready. Don't turn off your computer. It's been like that for like a half hour, so I don't know what's going on with that. But I need a new phone, man. This thing is such a piece, but it seems like we're okay for now. So we'll just cross our fingers and cross our toes. So
yeah, no doubt. Okay.
All right. Okay.
All right. Cool beans, everybody. All right, guys. So, all right. So today we are going to be talking about some classic boneheaded NASA screw ups that just prove once again that they are not a space agency. I mean, it's kind of ridiculous. They are a Hollywood film movie agency meant to give you the impression that we're going out to space, obviously. And it's ironic as much as they even tell you with all their verbiage, because, words do mean things, and they are very specific in how they word everything. And that's a big, big hint when you're dealing with these people that we're dealing with, especially at NASA. And I'm not exactly sure why the letter of the word or the letter of the law, so to speak, is so important to them. But, as long as there's a devious way around it, they, continue to operate in this way. And what I mean by that is, when I say that, people have the impression that we have tons of video footage and pictures from outer space and stuff like that, we have nothing of the sort. We have absolutely zero footage from outer space, and we have 0 pictures from outer space. And even the ones that people believe that are pictures from outer space simply are not. They're computer generated images, or they're paint, or they're painted, or they're stop motion, right? Another technique that they use. But this is the reason why NASA uses images. I still hear you, John. This is the reason why NASA uses images and the word images. And so, you know, it's just their way of doing things.
Cosmic law. Yeah. They can't lie flat out. I mean, the astronauts can lie, but like the organization itself, for some reason, they use those words. They're not telling you it's a photograph. They dance around that, and it's weird. It really is how they. It's almost like they're playing by certain rules.
Mm-hmm. Yep, I totally agree. So, John, are you able to hear us okay still? Oh, John. Wow.
Hello, John.
Oh, he is definitely having some problems. Well, hopefully he'll get it ironed out, and we'll just kind of move forward.
Yeah, here I am, and then I keep popping in and out of the call. I'm not sure what's going on, but I am here.
Okay.
But no, I said that composites. They're famous for using composites, is what they're doing.
Oh yeah, absolutely. Yes, the composites for sure. But we didn't hear that, so it's good that you repeated it.
Okay. Yeah.
So, all right. So anyway, there's a few things that happened in the news this week that were, fairly interesting with NASA. And so we're going to cover those. And then also today, guys, there's something that I want to talk about and report on, which I cannot report on YouTube. So towards the end of the show, I'm also broadcasting this currently on Rockfin, but I have it set on free mode. What that means is you can go to the link that's in there, and you can get into Rockfin, and you can go over there and listen to it, and listen to the rest of it from there. And I'm also broadcasting on DLive. I'm not exactly sure what DLive is going to do, but since I honestly don't really give a crap what happens to my DLive account, I guess we're just going to find out. So, yeah.
Well, thank you and the Rockfin for time months on that very, very generous donation. Yes, we definitely have a lot of things on Rockfin that we're excited to talk about. One of the things I'd like to talk about over there is what is free speech, what is illegal, or what are guidelines, what are different things that we have to follow. I'm probably going nowhere with this, but again, we are going over to Rockfin, and I'm very excited for the second part of the show. I really hope to participate in that one because I have a lot of things to add.
Okay, absolutely. And wow, Time, thank you so much. Holy cow, that was very generous.
Packed as of this last week.
Yeah, that was incredible. Well, thank you again, Time Months. Again, your support is really appreciated, and donations like that are awesome. And Bronco Moore, thank you so much for your tip that you sent. John Fibbich also threw a tip in there, as well as Tomo. And Time says for posting more old school episodes. Yes, Time. I told you I would do that, and I promise I will. So there you have it, Cami. Keep me on track. I told that I would start posting a lot more of our older episodes, and eventually I want to get them all up. But as we watched Brian Stavely kind of post, 10 million of his old episodes at once, and it kind of flooded everything out, I didn't think that was such a good idea. And, we're kind of at the other opposite end of the spectrum, and we're, not posting enough of our old episodes. So we need to keep those going. Maybe one every other day would be a good thing for us to do. So there you have it.
Or even one on each day that we don't have a show would be a good way to bring them on too. That's a great idea, Time. And I think we should do it. Yes.
Yep, for sure. So anyway, okay. So, well, let's talk about some of the stuff that happened this week. Some of this is just utterly insane. First thing I want to talk about is this first video that Level Earth Observer put out today. And you guys, you guys know that I love to highlight really good videos like this, and he has literally been on fire lately. He's absolutely incredible. He's a crane operator for a living, and he just has a really interesting way of looking at things. And I don't know where he caught this footage from because, I wasn't aware of this, but I don't catch everything either. So basically what I'm going to show you is his little video that is showing the guy that is in a spacesuit that's kind of chugging along out in space next to the ISS, blazing along at 17,000 miles an hour. And then we're going to talk about exactly why that is impossible. Okay, so let's go.
Today we get to see a space legend at work. Bruce McCandless. Bruce, in case you don't know, holds the record of being the fastest human of all time. Bruce, as you can imagine, is quite a hero to all the guys at NASA. But to appreciate Bruce's body of work and his record, we've got to go back in time. Back to the 80s, a time of great music, terrible special effects, hairspray fetishes, airfix models, and of course, the Jetpack Man. So take it away, Bruce.
Finally, in the spring of 1984, astronaut Bruce McCandless gently rose, untethered, from Challenger's payload bay into the vast expanse of space.
Here we get to see Bruce do a flyby, what appears to be Pangea. Incredible!
Sucky music. Ugh, geez, that's bad.
I wrote that song.
The maiden voyage of the Manned Maneuvering Unit, the MMU, had begun.
Well, that may have been one small step for Neil, but it's a heck of a big leap for me. Roger, copy that, Ray.
Yeah.
Now, if you thought Bruce's Pangea flyby was daft, wait till you see this. Here Bruce is supposedly going 9 times faster than a speeding bullet. Clearly ridiculous. This footage has aged terribly, and it's obvious Bruce has been layered in here and nothing is travelling 17,000 miles an hour. Ridiculous. What gives the game away even more is Bruce's voice. If you were travelling at those speeds in a spacesuit, there'd be some emotion in your voice. You'd either be a little bit scared, the adrenaline, or you'd be buzzing. But nothing here with Bruce. It's almost like he sat in a back room drinking tea and dunking his biscuits whilst doing the commentary for this. It's that obvious, just like the footage. So let's have a look.
For the first time in history, a man was flying in space, alone and untethered, in full control of his movements.
You guys notice
traveling
the
over
horizon
17
looks pretty flat to me, just saying.
Yeah, kind of.
For some reason, I'm not able to see the video. I'm not sure. Maybe I'm doing something wrong.
No, it's not you. You know what?
Fine.
You know what I didn't do, John, was I didn't share the screen for you guys. So I'm surprised Zack didn't say anything about that. Okay, start sharing. Okay, now you should be able to see it. All right, so let's continue on. And actually, you know what? Before we say that, let me first identify one really big problem with this, right? So you guys may have seen, I don't know, a few years ago, P-Brain came out with a video and he showed little bubbles coming off the space station, right? And they would twitch around and go left or right or anything like that. And of course, NASA said that these were just particulates, right, of matter. The problem is you can't have particulates of matter that have an inertia going in one direction of 17,500 miles an hour. And it's not only that, it's on a curved linear path, not a linear path, but a curved linear path. Because remember, it's dropping also at a speed of 17,500 miles an hour down, right? So that forward velocity has to equalize with that downward velocity. So here's the problem. The second that this guy disconnected himself from that, he disconnected himself from the alleged gyros that supposedly keep the ISS glued to the Earth, and its orientation fixed and all that stuff. But he also disconnected himself, from that angular velocity, right? And remind you, it's not linear. So if it was linear, yeah, he would keep going in one direction, but he has to not only keep going forward 17,500 miles an hour, but then he also has to keep dropping at 17,000 miles an hour. And that is not an inertia that will transfer to another object. In other words, where he would let off. Well, think of it this way. Think of it as if you had a sling, right? And you had a ball in a sling, and you swing it over your head, and you swing, and then you fling it and let the ball go, right? The ball is going to take off from the direction of that it was last headed, right? And it's going to continue going in that direction. So essentially the same thing is going to happen here. This guy does not have the same mass or anything like that. As soon as he disconnects himself from the inertia of the station himself, he's independent, right? He should just float away.
That's such a problem. And, I've sort of mentioned that and thought about that before, that the distance to the Earth and the velocity that the space station is traveling, that's specific to the space station's mass. The mass of a man is going to be a totally different velocity that you would need in order to keep the orbital, hypothetical orbit going. So yeah, it's a problem. It really is.
Exactly.
And how far away he is right now. I mean, he is already off in the distance.
Yeah.
How did they get him back? What did he do?
Well, he's just going to cruise up his little space thrusters and get up to 18,000 miles an hour, drive right over to it, or maybe 17,510 miles an hour. But I'm sorry, it doesn't work that way.
Yeah, but how does the little thrusters in his space shoot? What do they push off against? Where is he getting his traction?
They don't. And that of course is another entirely separate issue with outer space. Some people in the baller, obviously all of the people in the baller community think that rocket propulsion is possible in space. It absolutely is not. Not in a million years, nor can it be proven down here on Earth. It can be proven that it doesn't work. Most certainly it does, because if you can prove it by evacuating a box enough to where it doesn't allow any buildup of atmosphere from the gas that's coming off the rocket. So that means you've got to have several pumps working simultaneously, but it also has to be big enough that it doesn't allow enough atmosphere to build up in there to push off anything. But that doesn't matter, right? Because according to the ball earthers, it's not pushing off any of the other atmosphere, which is complete horse manure. It most certainly is. But that's not the point of this. This is a completely different thing. But you're right, Cami. There's no way he could be propelling off of anything, let alone, getting back the velocity that he would have lost. I mean, he would have literally just faded away at a really high speed, because no longer is he dropping at 17,500 miles an hour, nor is he flying forward at 17,500 miles an hour. And even if his space chute is keeping him at that, I'm sorry, their inertial masses are completely different. It will not work. It's just impossible. So let's continue.
15,000 miles an hour, 150 miles above the Earth.
Yeah,
We
right.
sure have a nice flying machine here.
Roger, it's a great team effort.
Listen to him. We sure have a nice flying machine here. Ridiculous, Bruce. And what makes it even more ridiculous is when we go here. Bear with me. So if that footage of Bruce wasn't bad enough, we're supposed to believe he's hurtling around this ball, navigating all this space debris in this animation, supposedly giving us the detail of space debris for 1984. Supposed to believe Bruce is hurtling around the ball, navigating all that.
Okay, so there's a question in the chat by number 6 who says, why would you believe the inertia would not remain the same? What force would cause a change in the astronaut's direction and velocity? Well, the inertia itself, number 6, you cannot preserve, you cannot get him to preserve that angular velocity at the same rate that the station is. And remember, the station is only able to stay with the curvature of the Earth and also keep its orientation to it, because there's supposedly great big huge gyroscopes on it, right? Which I think is complete BS anyway, but that's what they tell us, right? Because otherwise, how in the world would the space station always keep one side, the bottom of the space station, facing the Earth? Well, supposedly there's these big gyroscopes that are doing that. But the man's mass is different, and not only that, he has now introduced a whole nother factor into the equation. He's now introduced another direction in there, and not to mention his weight and his mass, and all of these things have just changed, and he is now separate from that station, and you cannot claim frame of reference. And this is, of course, is what they always say. Well, he's in the same frame of reference. It's like, no, it doesn't work that way. We're talking about absolutely real velocities. Well, as real as fairy tale gets, but we're talking about supposedly real velocities here, and he would be tracking with that. And he wouldn't be. He just couldn't be. It's not even possible. It's just so ridiculous.
Yeah, it's the same thing as if you had, water sitting on a tray in a car going 100 miles an hour, you turn the corner, the water goes flying off. If you're not tethered to that object and held down to it, your inertial reference is not the same anymore because of the mass difference. That's just how it works.
Yep, that is indeed how it works. So anyway, let's continue on with the video.
So to see this obvious bit of fake footage one more time before I go. No space debris, no satellites, obviously not travelling at 17,000 miles an hour. Clearly fake. Bruce has obviously been layered in. And Bruce gives it away with his voice. No adrenaline, not buzzing, almost bored. Who would be bored doing 17,000 miles an hour? Bruce, you blew it.
For the first time in history, a man was flying in space, alone and untethered.
Like he's really doing 17,000 miles an hour. I mean, look how ridiculous that footage looks. It's almost like a mannequin has been layered in there. Dear, oh dear.
Probably is.
In full control of his movements, traveling over 17,000 miles an hour, 150 miles above the Earth.
We sure have a nice flying machine here.
Roger, it's a great team effort.
Bruce, you blew it, mate.
Okay. So, yeah, I mean, sorry guys, but the inertial forces at play here simply will not allow that to happen. He would immediately be left behind, and what he should see is the space station descending at a really rapid rate, because where it lets go of him, he may keep a forward velocity for a while, but he's not going to keep that same downward velocity, because remember, it's being influenced by the gyroscopes. The orientation is being influenced by the gyroscopes on the space station, and his mass is going to be different, so he's not going to fall. And honestly, and I've questioned this before, and John, you may tell me what you want to think about this, but I've said this on more than one occasion. It's like, well, if gravitational pull or acceleration is 9.8 meters per second squared, right? So that means that it's squaring. That means that as you go faster down, right? The faster you go down, in order to keep in an orbit, you have to match that speed with a forward velocity, right? But the question then becomes, why does it stop at 17,500 miles per hour? Why do they stop there? What makes that happen? Is it because of the mass that of the space station supposedly still in the air, right?
Well, I think
still
what
a little
it
bit
is,
of air.
I think what it is like the radius of the Earth along with the mass of the ship, and that speed is what they came up with. I'm sure it was done mathematically to fit the big G constant perfectly. Is what they would have used is just theoretical mathematics, but I'm sure that's what it is. It's the radius of the Earth and the mass of the ship, along with big G, of course.
Yeah, exactly. So I'm just trying to figure out why all of a sudden that 9.8 meters per second squared equation stops at that velocity, right? And because that would indicate that you have a condition of now a terminal velocity, right? So when I was in the Air Force, and I did some skydives, we jumped out of the airplane and they told us, well, your fall rate's going to be about 120 miles per hour. That's your terminal velocity. And of course, it varies plus and minus from that, depending on how much resistance you put your body in, as to how much resistance you're going to put on the air, right? But in general, things fall at about 120 miles an hour within low or somewhat lower atmosphere, at least where you're skydiving from. Let's just say 10,000 feet, as a rule of thumb. So again, so I get that. And then when we saw Felix Baumgartner do his jump, and he did it from 120,000 feet, well, wow, he accelerated up to over 700 miles an hour. And then he finally started getting into an area of the Earth where there was starting to get to be some atmosphere. You could actually see his clothes starting to move. And then that slowed him down and slowed him down and slowed him down. And obviously at some point, theoretically, he would have also gotten down to that 120 miles per hour, right? But the thing that makes me wonder if, about that equation in the first place is why 17? Why 17,500 miles an hour? That seems to be the magic number, doesn't it? And that's just something that I'd love to have a baller answer. So any ballers, if you're out there.
So do skydivers that jump from about 10,000 feet, do they reach terminal velocity?
Yeah, you'd reach terminal velocity almost instantly.
Yeah, very quick.
Very quickly.
And again, I'm sure, because we know that they're not actually up there orbiting. So they would get these velocities from hypothetical mathematics where they're assuming, no drag at that elevation, right? Because there's no atmosphere up there to speak of. And basically they are falling, but that falling is counteracted by the forward velocity. And so they're sort of falling around the curve of the Earth, allegedly, right? Hypothetically.
Yeah, that's the whole description of orbit, right? You're literally falling around a gravitational pull. So it's a match of forward velocity to the downward velocity, and bada bing. So, it is, I don't know enough about that because I'm not an aerospace engineer, but it just seems to me that if that's the general rule of thumb for gravity, everything falling around anything would have to be put through that general criteria. The Earth falling around the sun, however you would figure that out, right? Et cetera, et cetera, et cetera. But we also know that you can do equations for two bodies interacting with each other, but the second you introduce a third, all of a sudden the variables become too complex, unless you're Reg Rhetoric, of course. But Reg Rhetoric says he can do it in his head. But then all of a sudden, he can
do a 20 body problem.
Yeah. Even the
Can he say that?
He did. He goes, "Oh, I could do that in my head." And it's like, oh God, seriously. He's unbelievable. So anyway, I think about that, and we do have an aerospace engineer supposedly in the community, and maybe I'll have him on here because I would just love to hear some of these answers. I really would. The last time that we kind of did a video on one of his responses, of course, it was the I Can Science That guy. And, he seems like he's a nice guy. He's unbelievably brainwashed. But I don't know. I really go back and forth because I struggle, because I know that, ballers will never concede anything. Not one single point. And his latest series of videos, prove that, because he's doing a series of videos on, well, what are the ball earth proofs and what are the flat earth proofs? And basically every single proof is for ball earth, and none of them are for flat earth. And supposedly he's debunked them all. It's like, what? Sir, you got to be kidding me. And of course we know that it's the other way around completely. So, when I think about that, I think, well, I don't even know if having him on would solve anything other than just getting more crap of like what you see on Nathan Oakley's channel, right? So I don't know, but I do think about it. So let me know what you guys think.
That's their favorite go-to is, I'm not going to defend the globe model. I'm going to tell you what you believe, which is not what we believe, and then pick that apart. They love making up our model for us. It's like, no, you guys should have this down by now. We've been talking about this for 6 years. The Earth is not a disk floating in space. Nobody believes that. Stop bringing it up. But
Yeah.
that's all they have.
Yeah, they can't even, and they still quote the Flat Earth Society, like that's going to be any good. It's crazy. So I don't know what to think of them, but every time I turn around and I see something new, it's like flat earthers are making outstanding points. Just like this one, Phuket Word came out with a new video today called Flat Earth Star Trails Explained. And, it's so easy to understand that perspective is something that, for us explains everything that is demonstrable, right? We can see from a perspective point of view that, like, if an airplane flies over the top of you, it's not changing elevation. And yet if it comes at you from the horizon, it's not actually coming from below your feet, but it's above the ground, right? And as we watch it go over the top of us, it appears to rise in elevation until it goes directly over the top, which it's at its highest elevation, and then we turn and we watch it go, and then it converges down to the ground, right? That's absolute perspective. But the ballers will never, ever, ever admit that that's the way perspective works, even though we have made 1 billion drawings and diagrams, John, of things, how perspective works. It comes in from the sides, up from the bottom, down from the top. I mean, that's the way our eyes work. That's the way perspectives work. That's the way cameras work. I mean, it's just amazing that they deny stuff like that. It just floors me. So anyway, on this video, he's talking about something that Chris Van Maitre pointed out, which I thought was kind of interesting. But if you look at this and look at the star trails, what's interesting is as you get further out, obviously these things are, getting longer and longer and longer, right? Why? Because they technically have to, cover more distance, right, in the same amount of time, right? Because we're looking up. And what this also tells us is because there is no parallax change between any of these, that there is no distance between them either. They are all essentially exactly the same elevation from the Earth, right? There is nothing that gives us any parallax indications whatsoever, unless you want to take the ballers and they say, oh yeah, no, it had 0.000 millimeters, whatever parallax, right? A really, really tiny number. And they get that from using redshift and blue shift incorrectly. But you don't even have to look at it that way. You can look at this, you can look up at these star trails, and you can see that these not only must all be the same distance up, but they are all traveling essentially, the same amount as far as with respect from their distance to the center, right? So, yeah, I just don't understand how they get away with saying all this stuff. So, John, you're actually pretty good on the perspective thing of this. I mean, and then of course when we get to the South Pole, we have the same type of perspective issue that's going on there, right? Except the difference is that we're actually seeing it come up, rise and drop. And you've seen the demonstration, the P-brain demonstration, where when you're looking at the perspective, God, what do they call it? What does Jeran call it? The
personal dome.
Yeah, the personal atmospheric dome. God, I always forget the name of that. The PAD, personal atmospheric dome. If you take that and you apply it, that explains everything. It explains, why we see those lines that appear to be going around a circle at a horizon. Of course, they're not, clearly. They're not, and they can't. But when you have the conglomerate of them that are out there, and you have some going underneath and some going over the top, then it looks like they're going around in circles, out at that. And that's, again, is part of the personal atmospheric dome. So that's all fine and dandy, but they will not take perspective into any other, area of observation, which is just incredible. Unless, of course, it is the side angle view, right? The side view, and the side view, of course, is their best friend because, you know, they can actually draw geometry on it, and they don't have to show, you know, what we actually see with our eyes. And so what they're trying to tell you is that they'll put a side on view and then tell you, well, see, the geometry works perfectly, right? And no, it really, really doesn't. So it's just crazy.
Yeah, they take out the angular resolution limit of your eye. They take all that stuff. They just remove that from the equation. And
Whoops, you broke up a little bit,
any
Zach.
device with a searcher. It's not just our eyes. Oh, sorry about that. No, this works with every device.
You're breaking
you
up,
look
Zach.
You're really breaking up, Zach. You need
with
to
a
get
circular aperture. Okay, I'll drop out and come back in.
Okay, that's
Yes,
crazy.
with their perspective, they tend to take reality out of all of their numbers. They pick and choose what to use, what not to use. On the red shift, blue shift, for instance, well shift, red shift, blue shift is well documented and is caused by a variety of reasons. I know they know of, I think, of at least 11, if not more, things that can cause this phenomena, and they randomly picked Doppler with things flying away and flying towards us because it fit best with what they're trying to say, not because it was a definitive answer. It's not that redshift can only be caused by Doppler, and they never tell you that. They just say redshift equals Doppler, and yet that was never decided on. So many facts were never decided on, and while we're waiting for Zack to get back, I'm going to jump forward and say thank you so much, Elizabeth Mickles, through the super chat. She had a question for you that said, I have listened and learned from you guys for years now, and I have shared your content with so many people. I love you and all you do. Does Rockfin allow you to download content? Thanks. I wrote back to her, I don't know, but I will ask before it's over. So do we know, or can our tech people answer this question?
As far
Can
as
you
I
guys hear me now?
Yep. Oh, we hear you great now.
Okay.
Yeah. As far as I know, you can download off Rock. You might have to use an offline downloader or an aftermarket downloader, like 4K downloader, or I personally use Wondershare All My Tube. So if you're familiar with that, Wondershare All My Tube, you go that. I think it was $20, and I bought it years ago, and of course they keep it current for you and all that. And that downloads virtually everything. It downloads Facebook, any online service. So, but there's plenty of free ones out there too. But I'm just saying what I use in particular. So yeah, you can absolutely download it. And if you're having trouble with that, let me know, and maybe I can send you something that you can get to work on Rockfin for downloading. So there you have it. All right. So here's another example of perspective, right? Flat earthers are always talking about how the horizon always rises to eye level. It's like, and the reason for that, it's not just the horizon, but everything on it also comes to eye level, right? So we're looking at basically 3 battleships here, or 3 ships, and 3 looks like F-16s, whatever. Okay, and as they are placed further away from us, maybe a kilometer or 2 or whatever apart, like that, each one of them, raises on the perspective of the water. Of course, obviously the planes are not on the water. We know that, but the boats certainly are. And, that's just the way things work. So you've got the closest boat is going to be at the lowest, the next, and then all the way back here, we have the horizon, right? And this is the very thing that Globers want to completely deny, is that this phenomenon happens, which is unbelievable, right? So,
the horizon rises with you proportionally with your elevation, which is something that couldn't occur on a globe forever. Like there would be a certain point where you get to a given elevation and the horizon should lower proportionally with your elevation, but it simply does not as far up as 100,000 foot plus when you get up in weather balloons.
Yeah, that's exactly right. And in addition to that, the sides and the top come in as well. As I said, if we observe something flying over the top of it, it appears that as it's coming over us, right, as it's coming to us, it's gaining altitude. And then once it goes directly over us, then it drops off and it starts going down again. Well, the same thing happens on the lateral sides as well. So you can see that basically he said, okay, well, say this was 1 kilometer here. And I don't know, this may or may not be accurate, but the idea of what he's showing is, so if it's 1 kilometer from here to here on this earth, then 1 kilometer would be about that here and about that here. In other words, it is coming in on the sides. It's coming in from the bottom up and the top down. That is absolutely the way things work, and there's no way that you can deny that, except the ballers do constantly. It's just beyond belief.
And an easy way anybody can go test this, when you jump in a plane, sit in one of the middle aisles or close to the middle and look out both windows. You can see the horizon out both sides of the plane. That should not be possible on a ball, especially the size they tell us it is. I think David did the math. It's like you should see an 80,000 or 79,000 foot drop compared to the distance that you can see when you're at that elevation. So the horizon even shouldn't be in either of the windows unless the plane is tilting.
Right. So basically, the ballers then respond to things like that of, you get people like Wolfie6020 that comes out showing his heads up display. And it's funny because his heads up display, this is what kills me, right? His heads up display is pointing at the true horizon, right? And it's pointing at something that is much higher than what you can see the horizon at, right? So what does that mean? That he's climbing? No, it doesn't mean that at all. It just means that from where he's at, his eyes or our eyes or anybody's eyes are not capable of having enough resolution to see that far to be able to see the atmosphere rise to that level. Okay. So again, a huge fallacy, and the way that they twist it around is unbelievable. And yet what Wolfie should be looking at on his heads up display is it's telling him, hey, the horizon's up here, and it's showing it way above that, right? Way above where he's seeing it. And it is correct. And the airplane is also flying towards that horizon, and that airplane is flying straight and level. But they try and turn it all kinds of around and twist it around and say, no, see, the horizon's down there, and you flat earthers have it all wrong. It's like, no, we don't. We just acknowledge perspective. So anyway, I got to stop ranting on about this because it just makes me crazy, and we all know that.
Oh yeah,
we all know it. So anyway, hat tip to Phuket Word on this video because it's really good. I really like what he did with it. So all right, so let me stop this one. Now this video I think is really interesting because this is another one of those videos, and the guy that actually came up with this was a guy called 10th Man, and he's on Nathan Oakley's crew. But basically, well, I'm going to just go ahead and play this and let Nathan Oakley explain what's actually going on here with star triangulations. And you think about this, we talked about this several years ago on Globebusters, but I think that they really did a good job of concisely explaining this and putting it together. But if you're using like an instrument out on the ocean, right, to navigate celestially, by the stars, well, you would have a problem if the stars themselves were not only curved in a celestial sphere, right, but if the Earth itself is also curved, right, there'd be a huge problem there because you would not be able to get any good triangulation locks on the object that you're trying to triangulate, right? Wouldn't be able to do it because again, you'd have to be compensating for parallax on the Earth. Remember Reds Rhetoric, how he had to do that when zooming in on the moon, when they were trying to figure out the distance to the moon? Well, they couldn't do that unless they added 0.6 of a degree for parallax for the curvature of the Earth, right? It's like, yeah, whatever. Well, the same thing would apply to those seamen out on the oceans trying to navigate celestially, except they have a double whammy, right? Not only do they have a curving Earth, supposedly, but they also would have a curving sky, right? A dome above the sky. And these domes are not necessarily linear or commensurate with each other. In other words, it's not like they were built together. But what actually is true, and this is the reason why this works, guys, what is true is that the stars are all at a very similar elevation. Wherever they're at in the firmament is all roughly just about at exactly the same place. And conversely, down on the ground, everything is roughly at the same elevation, at least to the point, when you're on sea level, then, it's definitely going to be all at the same elevation. Thus, celestial navigation works perfectly on a flat Earth model. But if you think about it on a globe, it cannot work. There's no way it can work. And this is explained fairly well here. So I'm just going to play. I don't remember exactly where this is. So I'm just going to play this really quick, starting from here.
Straight on a curved surface. That's correct. Welcome to Flat Earth.
Nathan Oakley, 1980.
Horizontal. Yes, that's
straight on the.
Okay. So this is a guy named Acumuvirus, and this guy is like dumber than a rock. I mean, oh my God. Yeah, I've definitely seen rocks with more intelligence than this guy. And you can tell, well, just listen to him and then listen to, what he says and how Nathan explains it to him.
To those stars are not dealing with the horizon, and you can make straight on the, you can make straight on the globe.
Sorry, you can't make straight on a globe? Yes, that's correct. Bendizontal. You can't make straight on a curved surface. That's correct. Welcome to Flat Earth.
Nathan Oakley, 1980. Follow.
I'm going to jump up a little.
That circle needs to be flat.
Yeah, that's why this line here is straight. And this line here is straight. And this line here is straight. And the line from your fix to the GP of the star is straight. And if you picked a star over here, and its GP was here, the line from you to that GP would also be straight, making every single elevation in this area flat for it to work. You sight the star. With this diagram, it's a little bit more weird because they don't draw the line out to the GP of the star for the triangulation, but it doesn't matter. It doesn't matter where you do it from. You're doing the exact same thing to achieve these three circles that will intersect at exactly the same point when you've got the position below where the star is. Just that simple.
If you can literally see the horizon, then you can make a straight line to it.
Welcome to Flat Earth. That's correct, and that is...
This guy has no clue even what he's saying. He just doesn't get it, right? He's assuming right then and there. Yeah, you can see it and you can make a straight line to it, but the only way you can make a straight line to it is if it isn't curving and the plane that it's on isn't curving, neither is the plane you're on curving, right? And he just doesn't get that. I mean, guy is just dumber than a box of rocks, but let's continue.
And it's
exactly how it's done in all...
Well, it's not so hard to wrap your brain around. It's harder for people to overcome the lifelong programming that we were all sort of subjected to. But I mean, I got to say, at least they're looking into it, and it seems like he's giving it a fair shake. And sooner or later, I'm sure he'll come around as a flat earther. I mean, usually they do, and because it's the truth. I mean, where else can you arrive at? I mean,
yeah, it's true for a lot of people, but not this guy. This guy he's like a professional troll that goes on Nathan's channel all the time. And, I've sit there and listened to him just go around in circles and circles and circles, and it's just like, my God, how can you be so dense? And it makes Nathan crazy. Of course, I don't, I get that.
If it gets to that level with the person, then sometimes you just got to sort of throw your hands up and either consider that maybe they are a paid troll or professional troll that are they're never going to concede the valid arguments and points, or maybe they're just a little slow.
Yeah, exactly. So anyway, let's continue on here, and I'll let him explain this out more.
A straight line to it.
Welcome to Flat Earth. That's correct, and that is exactly how it's done in order to do this triangulation. Welcome to Flat Earth.
Okay, yeah, I'm looking at the diagram now.
Right, the circle is just an area of land, all at the same altitude.
Oh, is that that's what y'all mean by needing to be the same altitude?
Yes.
Derp.
To achieve the result, this line from you to wherever the GP of the star is, or this one, can't be falling away from you, because if it's falling away from you 8 inches per mile squared, it would put each of these different geographical positions on a different elevation in three-dimensional space, and would no longer be capable of triangulating your position with, because the position above the star has fallen away from this triangulatable position if it's flat. So all of this area, which could be thousands of square miles, is all flat. If it wasn't, this would not work.
Nathan Oakley, 19.
And we know that it works because it absolutely, positively, people have navigated on the oceans using celestial navigations, using sextants for millennia, literally. In addition to that, we also have, Antikythera devices and, several other, tools that are based on a flat Earth. Why? Because they have to be. I just think it's so comical that Red's rhetoric got so busted on his triangulation of the moon. And that is the one and only thing that will actually triangulate to what they say that it will, right? But unfortunately, if you do those same calculations on the sun, it would also show the sun at about 234,000 miles away, right? So they just ignore that, right? Can't pay any attention to that. Just as they want you to believe that, the Earth is a sphere, but it isn't, and the sky is a sphere, but it isn't. This is all your personal atmospheric dome that is giving you this impression. It's as simple as that. So there you have it. So
and it's not like we're saying that there is like a bubble around you in any type of physical sense. It's just the distance you can see.
Yeah, it's subjective. It's a subjective bubble that is created subjectively for each observer by the atmosphere. Atmosphere behaves as a fluid on the macro level, and it combines at great distances to a convex lens around you. Is exactly what it does.
Yep, that's exactly right. So yeah, it's just something that the ballers seem to have this impossible thing. And of course, this is also why it's hilarious, because they claim once again also that this is the reason why the telescope, the mount, EQ mount of the telescope. Okay. The EQ mount of the telescope, the equatorial mount of the telescope. Okay. They claim that is, proof of the ball Earth. Well, why do they claim that? Well, because they're saying that if you take that and run it down the side of a globe, right, that it is, that you're actually, triangulating or not triangulating, you're working off of a point, one of the pole stars, either the north or the southern pole stars, right? Even though there isn't southern pole stars, it would be the Octanus constellation that they would be working off of. But the point is that when you back away from something that's directly above you, all of your perspective starts angling off more and more and more. So what they do is they take and they calibrate the EQ mount telescope on Polaris, right? And then they will put it on another star, which of course is also now appearing to have an arc around, right? Why? Because of the personal atmospheric dome. That's exactly why it works, right? And it also works because, again, those stars are also all on the same elevation, essentially, up in the sky. Okay? Otherwise, because if they weren't, guys, we wouldn't see them going around all at the same time and same direction and at the same speed. It's never changed. It never, ever changes. Ever, ever, ever. Right? So, again, what they've done is they've taken the perspective and ignored it. And they have taken this personal atmospheric dome and said, no, that's compensating for the Earth's sphericity, right? Which is bullshit. That's not what's happening at all. And P-Brain did a really good job explaining this on several of these videos. But
Celestial dome, schmalestial dome, I'm telling you.
Yeah, I know. Yeah. And that's the other thing, because people would think, well, you think that, if those stars really were at different elevations, at different heights and further out there, they would seem to rotate at different speeds with respect to, from the center out. But the only thing that we get is, you get something short towards the center, towards Polaris, and then it gets longer and longer and longer. And by the way, the sun and the moon, the moon we've also put in there too. And the moon appears to be even closer. Well, it is closer than the stars, but it appears to be a little closer, but not a whole lot closer than the stars, right? So the parallax argument just blows them away. It completely does. And they have absolutely got nothing at all.
Well, yeah, and the one thing that they actually claim that they have, the stellar aberration, they don't teach about. Okay, well, these stars parallax a little, but they don't want to bring it up because the stars correct themselves and move back into their original positions after a few years. So they don't even bring this up. They have a little tiny bit of parallax that they claim to measure, but when it resets itself and goes back to zero, it actually moves negative, they mark it as a zero in their column to the side.
Well, and if we're being honest, man, as a globe earther, my whole life, I sort of saw a problem with the the constellations never changing over the course of all of human history, right? Because I mean, you would think that if we are traveling through space with the galaxy, or around the galactic center and just constantly in motion, you would expect to see some relative change between the stars, relative to one another. And the fact of the matter is the constellations have never changed even a little bit. And I never could come to terms with this as a globe Earth believer. I was like, well, why don't we see sweeping changes, permanent changes in the night sky? And the fact of the matter is we never do. And the reason being is because Earth is not a ball flying through space. Space is not what we were taught. So makes perfect sense on flat Earth, makes no sense on ball Earth, just like everything else.
Exactly. And, as I've demonstrated many times in this before, here is our personal atmospheric dome, right? Which essentially, when we are looking at reference, when we're standing right underneath Polaris, right? Then it's straight up above us and everything seems to be rotating around, right? And that's exactly what we see. We see that in the time lapse. But the second you move away from it, then all the other stars start going with this action. And this is a property of vision, of perspective. And this is so important to understand because this right here kills the globe Earth and everything about it. It simply cannot stand up to the scrutiny. And this is exactly why that a EQ mount telescope would never work on a ball. Why? Well, first of all, if it was on a ball, then you would have the perspective that would still be at play, and you would have the rotation, the rotundity, the sphericity of the Earth, and you would also have stars that would actually increase in distance as you go further out, right? So you'd have all these different variables, and it would never ever work. It couldn't work. So that's just crazy. So this is so simple. It is absolutely so simple. So if you're looking at if you're down at the equator, essentially, right, and you're going with respect to Polaris down here, then you are seeing the stars essentially go up and come down, right? And this is exactly what we're seeing when we're down in the South America, and we're seeing these kind of half spheres that go around. But again, they're not full spheres because you're seeing some go underneath and some go over the top. Some go underneath and some go over the top. But again, perspective. Again, here you have the true stars up here, and then your personal atmospheric dome changes them to angles, which happen to be commensurate with the latitude lines. And of course, this is done very much on purpose, so that they could claim that, oh yeah, see, it matches the latitude lines perfectly. It's like, no, that was an engineering afterthought. They did that only because that's the way it was. They just claimed that it was because you were seeing it on a ball, and that's why with a radius of 3959. But there is absolutely no proof of what they say beyond that at all. And in fact, all the proof stands against it very strongly.
Yeah,
So-
and they've known about it for how long? Ares failure? That was a long time ago. And that experiment, without a doubt, proves that it's the luminaries moving and not the Earth.
Yeah, unquestionably. And that's a simple optical experiment, but they won't touch that. They will not touch that. In fact, what they'll do is they'll try and bring it into some relativity, type of, oh, this proves relativity. That's why. It's like, it doesn't prove relativity. I mean, this whole relative, frame of reference and relativity is horse manure. Things move with respect to each other. Yes, there's no doubt about that. But then there is also absolute movements. There are absolute directions. There's absolutely an up and an absolutely a down, and it does not vary anywhere. Okay. And, just like today, I was watching, oh gosh, what video was it? Where somebody was showing, oh, I know what it was. Let me actually pull this up. Let's see if I can do this really quick. You know how they talk about the Einstein pockets of gravity? That and they make that stupid demonstration.
Yeah.
That is
Oh my goodness.
Okay, so here it is. Here's this. It's on this video, which was by Kyle Adams and his response to Mr. Sensible and gravity, right? So Mr. Sensible is going to explain to Kyle Adams, how this works, right? And this is the most comical damn thing ever, but listen to how he explains how this works.
Cubes, and the warping is stretching those cubes nearer to the Earth.
Okay, wait,
your
back up a
path
little.
would be actually bend.
It was an acceleration. He said it was acceleration. There's a
Okay.
difference.
An acceleration towards the centre of the Earth. You need to think of it as a net, and I'll show you what I mean. Imagine the fabric of space and time just as a flat net of squares. Objects in space actually bend the fabric of space and time. The larger the object, the greater it warps it. If you're a ball rolling across that net, you travel in a straight line. If you got close to the Earth, your path would be bent by that warping of space-time. It will look as though the Earth has pulled you off of your path. Your path would then be deflected slightly. If you passed even closer to the Earth, your path would be deflected even more. Basically, you're trying to roll down towards it. That's the effect of gravity. Of course, space is a three-dimensional environment.
Yes,
so imagine
it
it
is.
as a stack of those nets, making little cubes. And the warping is stretching those cubes nearer to the Earth more and more. The closer you get to the Earth, you'll find that the net has been warped more and more. So you will continue accelerating towards the Earth. Here you can see...
Okay. This is such
Wow.
horseshit. Okay, first of all, he's right in saying, yeah, okay, then it would be a three-dimensional net, right? So why is it then that if things are getting in the gravitational distortion of space-time, do they roll downwards, right? I thought there was no up and down in space. Why isn't there a net up here on the top doing the same thing, or to the side over here doing the same thing, right? Why is it that they have chose to show that the universe, apparently under Einstein's model, has a preferred direction? This net is showing things only being influenced in the downward direction. Oops. I think that's a problem.
Well, yeah, and even a lot of pictures of their solar systems, you see these spiral galaxies, they call them, and they're flat.
Yeah, exactly.
And I just have a huge point of contention with the whole space-time thing. I don't understand. Yeah, space is a three-dimensional area. Okay, granted, but time has no sort of bearing or place in the three dimensions. To me, that's absurd. And it's almost as if Einstein threw that in there just to make it seem more complicated than it is. But this is just such nonsense. I'm sorry. I didn't want to get off in the weeds, but space-time, schmace-time.
Well, yeah, but they take us in the weeds all the time. Like I said, this whole argument, this is ongoing with Kyle, right? And, Kyle is trying to explain to him that, yeah, gravity definitely has its mysterious parts to it. And yet, I think we've come up, no, I wouldn't even claim credit for it, honestly. I took my model of the electrostatic gravity from the guys over at Thunderbolts, right? because the electrostatic dipole alignment effect made perfect sense to me at the time. And Zack has of course modified that and kind of elaborated on it with his videos on what gravity actually is, right? And our model.
And I got mine from MIT professor Walter Lewin. I didn't make any of it up. It's what he taught me.
That's right. And you were able to demonstrate yours, Zach. You absolutely were able to demonstrate yours. You could change the gravitational flow up from down, down from up. You were able to influence it by changing the bias on the object itself, the charge bias.
Yeah. And changing the weight of an object just by simply adding some more electric potential to it.
That's right. And that's exactly the way it works. You know, and that's something that's incredible, because they say, oh, no, sir, because if you put it in a Faraday cage, then that would tend to eliminate that. It's like, no. A Faraday cage, first of all, is a block for EM radiation, not electrostatic, right? You cannot block the charge potential of anything. Everything has a charge potential to it, right? Anything that is matter has a charge potential to it. You know, whether you want to believe that it's made up from electrons and neutrons and protons, you know, all these different charged particles, whatever. And even if none of that is true, and I'm not sure that's exactly correct as to how that works, but what I do know is that things respond to charge. And when you have a charge in a vacuum, then you don't have a charge. The charge isn't going to go anywhere because that charge needs to be able to propagate, right? So what do we have as far as the Earth? We have, on the flat Earth model, we have the Earth on one side, the flat Earth on one side. We have our firmament, our so-called firmament, on the other. And we have an absolutely mainstream verified measurements of 100 volts per meter per average, on average, of electrostatic potential in between these two things. Furthermore, when we have clouds that are rubbing together and causing all kinds of other electrostatic activity, we see not only discharges down towards the Earth, but we see discharges going up towards the firmament, right at about 62 miles, and they seem to flatten out like they're hitting something and flattening out at 62 miles. Again, we have evidence for it. We can actually demonstrate the way that it actually works, you know, for gravity. None of this is possible in their gravitational model, right? But the thing that makes me crazy, and I think this makes everybody crazy, is when flat earthers, you know, proclaim point blank that gravity doesn't exist at all, that there is no downward accelerative force. There is a downward accelerative force, guys. Come on. It is a... Of course there is. There absolutely is. There has to be. And without that, none of our equations would work. We wouldn't be able to calculate any ballistic motion. It's measurable.
Density and buoyancy only works if you have that downward tendency of high density objects. It's the only way anything works.
That's absolutely right. If you don't have that initial disequilibrium in the universe of the downward bias that's there, then nothing works. Relative density disequilibrium, I'm sorry, is just retarded. That theory is stupid. It doesn't make any sense at all. And it is all dependent on an initial disequilibrium in the universe. And that disequilibrium is caused by the static potential differential between the Earth and the firmament and any other object that's in there. But the key word here is, guys, is that it has to be in something that has matter in it, because without matter, you don't have any charge potential. And what I'm saying then is that if you're in a vacuum, then you don't have any static electrostatic field. Can't happen, because there has to be something that has to be charged. And if you are in a vacuum, then that can't happen. All right. Now, we have tons of examples also where extremely high voltages will cause things to, get sort of anti-gravitic effects, right? that's not the only thing. And there's one other factor in this too, guys, that a lot of people don't take into consideration, and that is rotation. And that rotation comes from the luminiferous ether itself. But that's, I'm digressing here a little bit. But, these things are not that mysterious at all in the first place, right? So, yeah. Wow, I really...
No, these are well understood laws of physics. I mean, these are the laws of electricity and how they work.
Yep.
We didn't make any of this stuff up. It's actually kind of breaking down one of the laws. Maxwell's fourth equation somehow magically says, oh, there's an ionosphere above us, and it has to be in free space. So now we can send electricity through a vacuum statically. And that goes against Maxwell's first equation. The fact that only 3 people have written papers on this over the last 100 years, physicists. So how many of these physicists actually comprehend the equations is my question.
Yeah,
they don't necessarily teach you to understand. They teach you how to operate and how to do them. It's a complete stack from reality. I do notice from the chat that a lot of people on there, when he's saying that density and buoyancy aren't like causing this, I think it needs to be very, very clear that density buoyancy is a very, very strong force within each other. But until you have a bias to set a direction, they can't take place. So he's not saying they don't occur and that they're not setting that or that they're not the cause of a lot of things. But without an initial bias, without a direction to go in, and without an initial my tongue is tied on the go ahead, disequilibrium.
No, you're right. The relative density disequilibrium theory is bullshit. I mean, it doesn't work. It falls apart without an initial downward bias.
Right, without a bias set, what determines down, and you can't just say down is down. That's not how it doesn't work this way. If you look at the numbers in the actual math, they're not symmetrical at all. Up and down are not symmetrical numbers. Down is ground. Up you rise at 100 volts per meter. It's, again, you're not looking at something that you could say or you can say again, on the sides, it does not work in reality. So you're taking the reality out of it, throwing that argument, which is not helping the flat earth much to, again, we need to leave reality. We need to find what's real, what's not. When they invented the ionosphere curving and being this like magical thing up there in Maxwell's fourth equation, again, this was a invention to solve the globe model, but nothing that was tested down in reality. Nobody is writing papers on it. They're not going to touch it in reality.
Exactly. And there's a comment in the chat from Pascalor who says, if the earth is flat, it isn't natural to begin with. Amen to that. And yes, it is flat. And no, it's not natural to begin with. It's very clear that it was engineered. Everything on it was engineered. Everything in it was engineered, as well as it itself was engineered, right? So, the ballers will sit there and say, oh, well, gravity won't work on a flat earth because everything has to go to the center of a ball. Oh, really does it? Now, let's take a look at that. Let's look at something. Let's go for some images here.
To that comment real quick, though, we were raised to believe that the universe is filled with spheres in space. Okay, and so that's why he would say that flat Earth isn't natural to begin with. But when you realize that the universe is simply not filled with spheres in space, space doesn't exist, and there are, as far as we can tell, no physical spheres up there, then I would say it is, in effect, very much natural. And the idea of spheres flying around in space is what is hogwash. So that's just my 2 cents on it.
Mm-hmm. Exactly. And so, you look at things like gases in space, nebula, things like this. Where is the ball that this is supposedly coalescing into? Why have we never, ever, ever seen a nebula coalesce into a ball? We've never seen anything coalesce into a ball. I guarantee you we have not.
Closet there anyway, though, isn't it? I mean, is that not space art? I mean, you can't see that with a naked eye or a telescope. Pretty sure that's
it's space art, yeah. But you can see you can see like hazy things that you don't really know what they are out there. But the point is they're not shaped in a ball, right? So whatever those nebula are or whatever, because a lot of times they'll call it a nebula. when you're looking at it through a telescope, and it's just kind of this kind of fuzzy. This is all dressed up very clearly, and all this stuff, and made to look like it actually is not. But it may even have, and this again is the art that shows little bitty balls. Well, again, why have we never ever seen anything coalesce into a ball, for out in space, right? There's no such observation anywhere. I had a telescope for like 15 years, and never once did I ever see anything coalescing in space. And it just doesn't happen. And half the stuff they tell us isn't even true anyway. That's why all of this, what you're seeing here, is nothing more than space art. And it's just utterly ridiculous that they claim this is what the Hubble is seeing. And when the Hubble is actually, just a telescope that's pointed out the side of a 747, and it's not this telescope that's out there.
They call it Sophia now.
Yeah, it's Sophia, exactly. It's so ridiculous. But look at this. It's like, where are these rules taking place? Where is this coalescing of things into balls? Where's that happening? Not seeing it. And you can sit there and go, well, this obviously coalesced into a ball. Oh, did it? Or is it just the way that it was designed? Is that saying like a light bulb? Well, that just coalesced into a ball, or maybe somebody manufactured it that way. I think I'll go with the latter. I think it was created. I mean, come on.
Yeah, there's a reason they don't teach us the Fibonacci sequence in school ever, no matter what grade you're at. They are hiding that thumbprint that is in everything.
Yeah. And that's the actually true reality is cymatics, and the Fibonacci sequence is behind cymatics, right? Or the phi ratio, because everything divine, has this Fibonacci ratio, phi ratio behind it, including the 5 platonic solids, right? And that basically makes up every other form in space. So, or every other form everywhere, actually. So let's look these up. Solids. So here they are, the platonic solids. Very simple. Tetrahedron, octahedron, hexahedron, icosahedron, dodecahedron, and of course you could top it all off with a sphere on each end, right? But essentially those forms, isn't it funny that the sphere is not even one of those forms, but yet it is kind of inferred. But I find it interesting that they're not even showing it as one of the platonic solids. Isn't that interesting? And I never really thought about that before.
The platonic solids, when you take it down to the beginning, the platonic solids are the natural crystal. This is how crystals form in nature. These are our crystal lattice structures. As a gemologist, I'm looking at the lines on the inside. These are all very, very familiar to me personally because I've done a lot of work under a microscope. But when you take it down into micro and macro, the platonic solids are nothing more than how rocks grow. Rocks, minerals, elements.
That's
I can't
true.
get simpler than that.
That's true. And it's interesting to watch crystals actually grow. It's bizarre. Cami has a video that she has on her channel. I think it's still on your channel, right? That shows the guy growing the crystals. Is that still on your channel?
Yes, I do. Yes,
Yeah.
I do. It does a fabulous, fabulous video. I think it's from the 1950s before they started. This is when they really were teaching. An instructor from the 1950s that was teaching and explaining how crystals grow and how it all works. And this is now, if you go to National Geographic and you buy a crystal growing kit, they're going to actually tell me this is not pure deception. They give you plastics and that and have you mold the shape of a crystal by pouring liquid into a mold and it molding. This is complete.
Oh, that's total deception.
This is what they're teaching our children, and yet the most natural, as children, if you put a string into water, sugar water, you'll see it crystallize around it. Your salt crystals. Crystals they grow. They're growing all of the time around you. They never stop growing. They've always been growing. It's kind of like grass and rocks do grow. The elements come together, they coalesce, they crystallize, and they grow in organized patterns. And the organized patterns at the basis, even though the outside, which you would almost call the cosmetics of it, because they grow together, can look rambled. When you take them down small enough, your everything is based on these platonic solids.
Yep.
And I think
isn't it amazing? The platonic solids are, in fact, they're very crystalline looking when you look at them as a cymatic manifestation, which is nothing more than a very resonant type of
charge alignment.
Charge alignment brought about by, primarily like the esophageal type of frequencies that bring forth these beautiful, beautiful waveforms, right? Because everything.
And those are your solids. Those are them. You're right. You're spot on.
Yep. It's exactly right. That's how it works. So, I mean, it's just so amazing. And of course, they never taught any of us about any of these things, right? That's why we like to do shows on this. If you guys didn't see the show we did with Baltini on, how matter becomes form and stuff, that was a really good show. I don't know, a couple months ago. Check that out. But, we are so in the dark and so completely lied to about everything that it's just mind-boggling. But today, unfortunately, we're facing many more problems than just the flat Earth. And that's the really sad part. Just when the information starts coming out about flat Earth and about the true nature of creation and what's actually happening and how it actually all works, then of course we've got to be distracted by something else, which is, I guess, the part of the show that I want to go to next. And in order to do that, I need to shut off the YouTube stream, guys. So if you look in the Globebusters show description, you will see two links in there. One is to Rockfin, one is to DLive. And if you kick over there to that, and we will watch the rest of the show from there, because honestly, I can't show this. I can't talk about this on here. We'll get shut down, and I don't want that to happen. So there you have it. So,
okay,
everybody,
for people, moving over from there, this is not a paid show. You do not need to be a subscriber or this. There is no charge for this show. It is just with YouTube. We are not allowed to speak freely, and we are over at Rockfin, and so it will open it up a little bit for us.
Yeah, and DLive as well. So I'm broadcasting on DLive too. I don't know what will happen with DLive. I do know they do take some stuff down, but I honestly don't give a crap if they take down my DLive. But we're dlivE/Globebusters-FE or rockfin.com/stream/8120 NASA blah blah. Anyway, it's in the link. And mods, go ahead and paste it in. Paste those links in for everybody to go over and see. And let's go ahead and end this particular stream and head over, and we can talk about what else is going on that YouTube wants to keep secret because they're bastards. Okay, so hopefully I have made that clear. Guys, there is no subscription cost. This is free. Either DLive or Rockfin. I'm not going to say it again because sure enough, somebody's going to say, well, what happened? Because you weren't listening, okay? It is on Rockfin right now. It is free. It is no charge. It is on DLive. It is free. It's no charge. We are moving over there right now. So I'm shutting down the YouTube stream in just 1 second here. I actually have to get back into the YouTube studio so I can cut it and go to live. And there's that. Crap. Why do I do this all the time? Makes me crazy. All right, hang on a second. Say something, John.
Morgal, are you there?
Technical difficulties.
Yeah, experiencing technical difficulties.
While we're doing this, I'm going to talk about free speech, what it is, what it isn't, and why we are broadcasting what we can and cannot say at Rockfin. Free speech.
Okay,
we all want.
I'm going to end it right now. Okay, we're ending it now. Go to Rockfin, go to DLive. YouTube ends right now. And YouTube has ended. Okay.